Hi, so here are the quick answers for page 4, and I'll go through all the answers for the rest of the video slowly. So pause if you want to look at them, otherwise let's go through them. All right, an elevator is moving upwards at a constant velocity, so straight away that gives me an idea that in this case, net force is 0, or total force is balanced. Passenger has a mass of 85 kgs. Construct a force diagram for the passenger. So I'm just doing the passenger. And this box helps tell me what's interacting with him, because our definition of a force is an interaction between him or her and something else. So at the moment it only looks like the floor is interacting with the passenger, and of course gravity can do it magically without touching. So got my force of gravity on passenger by Earth, and I've got my normal force on passenger by the floor, and those are the same size because the net force is 0. Right, calculate the force the floor exerts on the passenger. Well, I don't know any formulas for normal force. They want this one here. The floor is exerting this force here. But I don't, if I look at my formula sheet on the front of this yellow book, I don't have a formula for normal force. I don't know that. But what I do know is the normal force is equal to the force of gravity. And I do know how to work out the force of gravity on this passenger, because that is mass times the gravitational field strength. In this case, it's 85 kgs times 9.8 newtons for every kg. And that equals 833 newtons. The same elevator now accelerates upwards. Important, okay? And it's telling me that the acceleration is in an upwards direction. Construct a force diagram for the passenger. So I now know that the total force is upwards. So I might just write that down. The total force is upwards because the acceleration is upwards. So my force diagram has to show that. It has to show that somehow my downwards force, force of gravity, and my upwards force, normal force, combine to give an upwards force. And the only way that can happen is if this force is much larger than the other force. Okay, I'm not going to write the, well, I'm going to write them. On passenger by Earth, on passenger by floor. So now I can't put the equal signs because they're not equal anymore. So write an equation for the vertical forces on this passenger. My equation is really what I've drawn here, but written as an equation. I've said the total force is equal to these forces combined. So my total force, which is this arrow, is equal to these ones. So it's equal to the normal force, and then I subtract off the gravity force. Makes sense, because if I subtract this arrow off from here, I get left with this one here. So using this, calculate the force the floor exerts. And now I still want to work out my normal force. It looks like it's bigger than gravity. Okay, do I know, let's write this out again. I've been asked to work out the force the floor exerts. Okay, that's the normal force. So I'm going to rearrange this, rearrange this to find N. I'm going to add Fg to both sides. Now I have total force equal plus Fg equals Fn. I know how to work out force of gravity. It was just 85 kgs times 9.8 newtons per kg, and I've got that 833. Do I know how to work out the total force? Yeah, well I do, because now I've got this new formula, MA. And so total force equals MA. I've got the mass of the passenger is 85 kgs, and they're now accelerating at 2 meters per second squared, and that equals 170 newtons. So now I've got all these numbers. I've got 170, plus 833 newtons. And if I add them together, I get 1,003 newtons. Is that it for that page? It is. Well done.